All right, picking up part two where we left off, we had the first practice problem there, kind of all laid out how you start with 4.56 moles, and then you're going to multiply it because the 6.02 times 10 to the 23rd that we put in our brackets or our parentheses, if they're on top, you multiply. If one's on top, one's on bottom, you divide. So you end up just multiplying those two together, and you end up with 2.75 times 10 to the 24th. On any of these practice problems, if you have any questions, feel free to email how to set it up, and if you're not getting it from the explanation. Same thing here on the second one, how many moles of water? Start with what's given. This one's going to be the opposite because I'm going to start with the 5.87 times 10 to the 22nd molecules, and water, H2O, because it's covalent, is a molecule. You have only one step problem. But this time I'm going to put in my parentheses, I'm going to put the 6.02 times 10 to the 23rd molecules equal to the 1 mole on top. So the bottom is the 6.02. And like I just said, if one's on top, one's on bottom, you take the 5.87 times 10 to the 22nd divided by 6.02 times 10 to the 23rd. And I would hope that's what your calculator gives you. Now, if we look at atoms, this one's a little bit different because this here, C6H12O6, glucose, ends up giving us a molecule. So when I say whatever that is in the problem is what you have to put in your parentheses. Still start with what's given. So 1.23 moles, but now I'm going to put the 1 mole on the bottom and the 6.02 times 10 to the 23rd molecules on top. I know that doesn't finalize the answer because I want to find atoms, but I have to put what this actually is. This was water, so it was a molecule. This is carbon dioxide. It was a molecule. Well, this glucose is a molecule. Doesn't answer the question because I need to figure out atoms. So, but I still start with 1.23 moles, and then I put on the bottom 1 mole is 6.02 times 10 to the 23rd, so the moles will cancel. I multiply those two, but now I got one more step because how many atoms of carbon are in this one molecule? So then I would put 1 molecule on the bottom, so my molecules will cancel, and I'll put 6 atoms of carbon on top. And then I just multiply all three together, and you would get, hopefully on the real PowerPoint, you can see that, 4.4 times 10 to the 24th. Now, it doesn't have to be all of those were molecules. This one here can be a formula unit. That's why it uses formula units. But always start with what's given. 7.78, this right here, times 10 to the 24th. It's a formula unit. So I'm going to start with that. And then in my parentheses, because this is an ionic compound, it's always the representative particle will be a formula unit. I'm going to say on the bottom, 6.02 times 10 to the 23rd formula units is equal to 1 mole on top. Then the formula units will cancel and I'll be left with moles. But what do you do if the number's on bottom? You just divide. Again, that's a lot of stuff in that small amount of time, but it's all conversion problems that we did in Chapter 2. Now, when you're finding masses, those are all if it's a representative particle, an atom, a molecule, or a formula unit. Any of those in the problem. Now, if they ask for mass, it's going to be different. We have to get that off of the periodic table. So if you look at carbon on the periodic table, it's 12.01 on the bottom as far as an average atomic mass. We're just going to say that there are that many 12.01 grams in 1 mole. So it allows us to be able to use that because that's what's called a gram atomic mass. It's the molar mass is what we will usually call it. The molar mass is what's on the periodic table, but it's for one of those things. So like I said, that becomes our conversion rate that we can put in our parentheses. We could put the grams on top and the mole on the bottom, or we can switch those. Example, so what do you start with here? The 2.34 moles on top. Now, if it's anything to do with mass, not number of atoms, number of molecules, number of formula units, if it's mass, I got to get the number off the periodic table, not use 6.02 times 10 to the 23rd. So you got 2.34 moles. I'm going to put 1 mole on the bottom, and then I'm going to put 12.01 on top. And again, the same thing becomes, I multiply because that's going across the top, 12.01 times 2.34. This one's going to be the opposite. Why? Because what am I starting with? 24.31 grams. That starts my thing. And then in parentheses, I put the grams on the bottom of magnesium. And you get that off of the periodic table. And if that number's on bottom, you just divide.